In this video, I would like to discuss how we can evaluate trigonometric expressions in any of the four quadrants of the unit circle. We need to remember that on the unit circle, the x value of a terminal point is the same as the cosine of that angle, and the y value is the same as the sine of that angle. So I want to begin to think, where are cosine and sine positive or negative values on the unit circle? Well, x is positive in quadrant 1 and quadrant 4. X is negative in the other two quadrants. Y is positive anywhere above the x-axis, so in quadrants 1 and 2, the y value is positive, which means sine theta is positive. Y is negative below the x-axis in quadrants 3 and 4. We also need to note that angles with the same reference angle share the same values for x and y at their terminal points, except for possible sign changes. Here's what I mean by that. If I have a 45-degree angle, for example, with the terminal point root 2 over 2, root 2 over 2, as we saw in the last video, and I compare that to, say, a 135-degree angle, 135 degrees also has a reference angle of 45 degrees. The terminal point will be essentially the same, but the x value will be negative because x is negative in quadrant 2. I could compare that to another point in the third quadrant. In this case, the values would be the same, but both of the values would be negative. And I could compare that to yet another point in quadrant 4. All of these angles have reference angles of 45 degrees. That's how far they are from the x-axis. And in quadrant 4, my value would be root 2 over 2, negative root 2 over 2. So as we work our way around the unit circle, we begin to see that we really only need to refer back to the first quadrant of the unit circle, as I've highlighted here. Every other quadrant of the unit circle repeats the same values for terminal points. It just changes the positive and negative signs on x and y. So here's how I like to use trigonometry on the unit circle. If I'm evaluating a trigonometric expression using the unit circle, I follow these 3 steps. First, I find the reference angle. Second, I use the terminal point for that reference angle from my diagram boxed in here to evaluate sine or cosine. And third, I determine the sign that's based on the quadrant that our angle lies in. Let's walk through that with a couple of examples. If I want to find sine of 3 pi over 4, it would help to draw a sketch of where this is located. 3 pi over 4 is exactly right here in quadrant 2. This is pi over 4, this is pi over 2, this is 3 pi over 4. So 3 pi over 4 is located right here, and it has a reference angle of pi over 4. So step 1, find the reference angle, and in this case, that is pi over 4. Step 2, we're going to use the terminal point for pi over 4, or 45 degrees, to determine sine or cosine. So we know that sine of 45 degrees is the y value of the terminal point, which is root 2 over 2. And third, to find sine of 3 pi over 4, we're going to use an absolute value of root 2 over 2. We just need to determine the sine. I'm in quadrant 2 for the angle 3 pi over 4. The y value is still positive in quadrant 2, so my answer is still positive. Sine of 3 pi over 4 equals root 2 over 2. Our second example, find cosine of 5 pi over 3. 5 pi over 3 is very close to 6 pi over 3, which is the same as 2 pi. So 5 pi over 3 looks like a quadrant 4 angle. Here's our angle, 5 pi over 3. And it has a reference angle of pi over 3. Remember, to find the reference angle, I can subtract 6 pi over 3 minus 5 pi over 3. So step 1, identify the reference angle. It's pi over 3, or 60 degrees. Step 2, I want to evaluate cosine of 60 degrees using my diagram above. So cosine of 60 degrees is the x value of the terminal point. And here we see that is 1/2. So cosine of 60 equals 1/2. And step 3, to give the cosine of 5 pi over 3, I simply use the absolute value of 1/2, but also determine the sign. The x value in quadrant 4 is positive, so we stick with a positive answer. Cosine of 5 pi over 3 equals positive 1/2. It's important to remember that when we're evaluating sine or cosine of an angle, we're carrying out an evaluation of a function. The input is an angle measurement, 3 pi over 4 or 5 pi over 3. The output is a real number, so we're looking for an output number of, for example, root 2 over 2, or 1/2, or 0, or 1. Those are the output values for the sine and cosine functions.